Welcome to the session on technology frameworks. We're going to discuss in this session what exactly is a framework and what are the value additions of using a framework in today's technology programming scenario. Now, if you look at the diagram that I've got here, we have the operating system as the base layer that you would typically install on a standard PC to get the PC running. On top of it, we are looking at installing another layer which is a framework that would allow us to interact more effectively and efficiently with the OS from an application development perspective. What is that we are trying to do here by targeting the framework and not the OS directly? I am going to take a scenario where we look at creating a small little application in a very legacy technology like C and C++. If you look at creating a file in C++, the first thing I would do is write my program. The moment I create the program, I would look at checking whether the program has any kind of errors and whether it is capable of executing post deployment onto the operating system. Now, the process of checking if the program has any errors is what I would call as compilation. Once I compile the program, what I would get as an output is some format which is capable of executing on the OS by using the hardware infrastructure that a PC or a standard computer would offer. What I would get as an output post compilation would be something we call as machine code. The moment I have this machine code, I simply would deploy this onto the client's machine. He would double click on it and execute the application, which would then display some kind of output. The problem with this kind of model is the machine code that is generated here is specifically targeted towards a particular processor and towards a particular operating system. The moment I swap the operating system or my customer purchases a new PC or a new laptop with a new OS installed on it, the same application is would not be able to function there. What do I do then? Do I ask the client to go and invest in the same software which I would expect him to use in terms of the operating system? Well, that wouldn't be very customer friendly because I'm not giving my customer options to pick and choose what he wants. What I need to do is some mechanism where I create an application which is capable of functioning on any kind of hardware platform and any kind of operating system. And that's where the framework is very important, because what we do is we don't directly create executables that target the OS, we create executables that target the framework. The benefit of doing that, you keep swapping the layer that we have right here at the bottom in terms of the operating system. So you tomorrow have a Linux, you have a Mac OS, you have a Windows OS, it doesn't matter. As long as you've got the framework installed for the right kind of OS, you have capability of executing your application on any kind of operating system. So how does this compilation process actually run? Now, this is option 1, that we used a legacy technology like C++. In option 2, I'm going to use either Java or C#, which are primarily .NET and Java based technologies, C# being a Microsoft .NET technology and Java being an Oracle J2E based technology. Now, the moment I create a program that I write that I would expect to execute on any kind of target OS, and I again go through the same step of compiling it, what I would get as an output is not directly machine code that is targeted to a particular processor, but what I would get is something called as intermediate code. If you are working with the J2E platform, The J2E bandwagon refers to this as bytecode. If you are referring to a Microsoft solution, the Microsoft community refers to this as intermediate language. The benefit of having this intermediate code is this is something that we today call as portable code, because the moment you copy this executable onto the client's machine, it doesn't matter what kind of OS he has. All you need is a specific framework targeted to that specific OS to execute these kind of applications. The benefit of which is it's now completely platform and hardware independent, and that's the reason this format is what we refer to as a portable executable, because it has capability of porting to any kind of hardware and software platform. Post this, we are going to go through another compilation which will finally go and give me my machine code. Now, how is this different from the scenario that we've put up in option 1? The difference is that these two steps out here are actually happening on the developer's machine. But these two steps out here are what happens on the client's machine. Now, if you look at the difference, we are not looking at taking code and directly converting it into machine language. We are looking at converting it into something intermediate, which is then copied onto the client's machine, and we expect the framework installed on the client machine to take that intermediate code and give us the final executable, which would be specific to that OS and that hardware platform. The benefits of doing something like this are obvious, because now when the client keeps swapping and upgrading his hardware or changing and upgrading the OS that he has, as long as he has the updated framework version, our code continues to run on his machine. The benefits in terms of cost savings also are huge, where you don't need to sell solutions to your client asking them to keep sticking to a particular set of hardware and software standards, making it a complete open-ended solution that is being proposed by your organization. That's it in terms of leveraging the benefits that frameworks have today. Thank you so much.